So hello, Marlon, and thank you for coming to our workshop today.
Thank you for having me.
I've known Marlon, I think, for the past couple of months now. We've been exploring this part of the Maltese islands, I think now for a number of years, thanks also to Mike Desira, who is possibly one of the very first builders that we know of locally. But most recently we've come to know a bit about yourself and also about the name Electronified. Marlon, can you give us a bit like how everything started from when you were young? I think you had a passion for electronics in general, and also you had the brand already in mind, the name.
So I started getting into electronics since a very young age, since I was 8. At first it was just breaking stuff and seeing how they work, but eventually I ended up studying electronics and focusing more on following this path and career. The name Electronified has been, you know, when you grow up creating things and dreaming about the future, you end up also thinking about a name, so it's nothing special, but it's a simple word that wasn't even in the dictionary, so I decided to use it to be something unique, that's all. But yes, I've been into electronics from a long time. And
you say you studied electronics, so you went to a particular course in the local institute?
Yes, I studied electronics in MCAST. I graduated as a technician, and I followed the electronics technician career.
Exactly, and currently you are employed as a technician, no?
Yes, I'm a lift technician by trade.
So hence you are very much specialized on mechanical type of electronics.
Yes.
Yes.
Having dismantled a lot of hi-fi and cassette decks and long play machines.
Okay, we'll come to that later.
You end up learning more about mechanical, yes.
So, so you're growing up and you're listening to music too. And what was your favorite music as you were growing up? Maybe the places where you used to go to listen to.
I've listened to a lot of electronic music in my life, and a lot of techno, a lot of electro, a lot of house music, acid. And about 7-8 years ago, I started realizing that all it is patterns and noises. So eventually you start figuring it out, and I discovered about modular synthesis. At first it wasn't really about modular synthesizers. I just created machines that created sound. But eventually you start running out of space because you have a lot of small devices running around, so the solution was a rack. So I started focusing on Eurorack.
Yes, so you went to some events locally, I would believe, and you saw some performances too?
Yes, of course. I've heard you playing live, for example, Do a Blank. I've heard, for example, Ansam once came live with his deck, with his modular synthesizer. I've heard even online, of course.
So it was modular, so the aspect of modular that truly inspired you to then move to start building noise devices and...
Yes, modular is something of its kind. It's different from mixing music, just mixing music. It's about creating the sounds. I'm not a musician, but I enjoy creating the sounds.
Okay, so let's start now exploring a bit what you brought here. But I'm going to ask you, what was the very first device that you built, and when was that?
Oh, the first device that actually created a sound was just a simple drone using a 555 chip. And then you start cascading the 555 chips that one drives the other, and there's a circuit called Atari Punk Console, which is very, very, very easy to create. And I started improving from there. So the first devices were simple devices in reality, and a small speaker and a battery, nothing.
So when we say this 555 chip, this is used for general applications?
Yes, it's a clock chip. It creates a square wave. You can also pass with modulated, so you can vary the shape kind of the square wave, and you can make them also fight each other. Basically, you can create two circuits sharing the same output, and they start kind of creating noise together.
And this is nothing very expensive, so we're talking about some very inexpensive, yes. I would say.
You will burn a couple in the face.
Yes.
It's okay.
How much would a 555 chip cost typically? Cents, I would say.
You have to buy it locally, not more than 20, 30, 40 cents, not more for sure.
So here, so you start off building a simple square wave oscillator by spending a chip that costs less than 50 cents, so which is fantastic. And obviously it's fantastic because when you're building, you're testing, and when you're testing, stuff
learning.
might get burnt, and hopefully you don't get electrocuted. But I think that's part of our passion. Comes the shocks come obviously one always tries to take as the, let's say, the precautions, the usual safety precautions. You started building these devices, but these weren't mechanical. No, these were just simple,
electronic, yes.
I would say solid state, just kits. But then you started also moving into the mechanical. How come?
So when it comes to sequencers, to create an eight-step sequencer, it's relatively easy, just electronically, unless if you work only with chips, not with coding. When you start evolving into bigger sequencers, for example, the 16th step, there are more complicated circuits, or you can go digital. But then you start realizing that all it is just inputs changing from one to the other. So I said, maybe it can be done mechanically. And this idea came from to create a wiper that goes around, and the wiper is energized, and it's hitting the steps one by one. And I created this one of my first mechanical devices.
So this is as such your master clock, the master clock for your sequencer, no?
Yes, once
and
it was, yes.
It's in a sort of snow globe type of glass enclosure, which you bought from one of these shops, souvenir shops, no, in Malta.
Yeah, so just something. I keep a lot of stuff that I can use in the future, and this was one of them that I decided to put it in. If it fits, I put it in there.
So can we try it out? Can we start trying out the first device? I think this is the oldest device you have here, no?
Yes, hopefully it still works.
Yes.
No problem.
So this is the clock part of it, which is touching a lot of contactors there, no?
Yes. Let's see.
Take your time.
Let's see. So this is a sequence of on and off. Just simply going in a filter. Then obviously I can change.
Okay, so this is a trigger sequencer.
Yes, this is a just triggers, just on and off, going in a filter, which is filtering a simple.
And you can
wave.
accelerate and decelerate,
Yes.
This device.
Yes.
So basically what's happening with each and every contactor, you're getting a pulse there, and you choose which of them will output a trigger and which of them won't.
Yes, exactly. It's creating a simple square wave again, selecting which pins of the sequencer are active or no. So the wiper is energizing them, but then the sequencer decides if it lets the signal through or not.
And you have two, they are similar to each other?
They are the same,
the upper and the lower?
So I created several channels to come from the same sequencer. There are 6 channels, actually there are 12 in this one. So I have, I can take each output can go to different sounds, which then are mixed
like
together.
Drumming, for example, you can trigger
yes,
the drum module from here. And these are normal jackouts that can be connected to something like a Eurorack module.
For example,
excellent.
yes.
Okay, نستنى Yes, so again, this is not something very expensive. It took you a lot of time to develop. How much something like that took you, roughly?
If I had to do it now, it wouldn't take too much, but
Yes.
since I was creating everything from scratch, then yes, it took a lot of trial and error and designing with software, the PCB, and ordering and waiting for the post. So it took maybe 6 months to create this one, yes.
But it was your very first, so this was the device that introduced you to, introducing you to the world of noise devices and eventually the world of Eurorack. Are you inspired online? We all know there are so many YouTubers that develop these kits and that constantly, some of them look like mad scientists. Are there? I would believe there are a couple of them that inspire you to build your equipment.
In electronics, you never stop learning, so you always end up researching and watching videos that people. But people that really focus on modular synthesizers, obviously there's Lukman No Computer, which I've been following from almost his very beginning. And also, if you want to go more technical, is Moritz Klein on YouTube as well, which goes deeper in the circuit building and the mathematics behind it, which gets more complicated, but it's nice to learn some of those things.
Exactly. And from a cost perspective, now you say if you had to rebuild it, you'll build it very quickly. Something like this, did it cost you a lot of money to even? I would believe you ordered the PCB from abroad. The
PCB design and ordering is the most expensive part. Let's call it like that, because the post and the designing, there are a lot of fees, hidden fees. But the components itself, if you buy online from China, for example, it gets really cheap. The more you buy, the cheaper they become. And I ended up stocking parts which I don't need for future use, because it's more affordable like that, convenient.
Okay, good. So let's move on to another of your. We'll start exploring your two suitcases here, and they look like I don't know if you know what the football is, but the American president has got someone next to him that always has the codes for the, God forbid, the launching of. And believe me, these look like the footballs because they have all those switches that would trigger, God forbid, the launching of some nuclear missile. I leave it up to you. Maybe you can take us through. These suitcases. I'm seeing also, and this is an interesting part that I would like to discuss with you. I'm seeing cassettes. I'm seeing reel-to-reel tapes. I would believe that even these devices also inspire you a lot, and you are a collector also of reel-to-reel tapes too.
Yes, so tape was always something that you can say I grew up with. I'm from the 90s, so tape was common in that time. As I said, I used to buy a lot of hi-fi devices, broken ones, just to dismantle them, to take parts from them. So I ended up with a lot of mechanisms, tape mechanisms, and slowly you end up learning how they work. Tape in the modular world is not very common, but it's used. But you don't see many modules that actually work only using tape. There are a couple of delays that use tape, but I decided to take a Walkman, a simple Walkman, take its mechanisms out and put it on a module. And I created this signal generator. I recorded a simple sine wave on the cassette, which, if it works, we can hear. That is a simple sine wave coming from a cassette. If you put a variable speed controller on the motor, you can make it go faster, so you change the frequency, or you can make it go slower. The nice thing about a signal coming from a cassette is the wow and flutter, it's called. It's basically, you're not hearing a clean sine wave, you're hearing the defects of the mechanism. There is the rubber belt, which is stretching and releasing. There is the motor, which is not perfect. And there are also the gear wheels inside, which also are not perfect. So if you listen closely, maybe it's not very... But you can hear that the sine wave is varying a little bit. You can hear it like jumping slowly. And that's called the wow and flutter. So it's a nice effect to add maybe to certain types of music. But it's also a one-of-a-kind machine that I created. Is nothing too serious, but I think the idea can be evolved.
Yes, this is in fact, I would say, another aspect of sound fetishists, that we look at imperfection. We've now been used so much to digital and to its perfection that cassette and even reel is something that inspires one, because reel is great even to master stuff on when we're talking quarter inch. But cassettes are great because of their unpredictability, the motor that shifts and creates this wow and flutter. And here, well done, you created something which is like the oscillator of a setup with a wave. I believe on the other side you have another frequency, no?
Yes, there is that 300 hertz frequency on side B, just to have another range of frequencies if you decide.
Exactly. Let's continue to explore this this part of your setup. Maybe we can go through the devices you have there one by one. And are these Eurorack or they are not Eurorack or are they custom format?
I tried to follow as much as I could at the time because I honestly I've never owned a Eurorack product, so I never bought a module. But I researched online and found the dimensions, and I tried to keep everything as a standard, as the Eurorex standard. So the dimensions are correct, the mounting holes are correct, and the power supply connection is the standard one. So yes, if you want to mount them in a Euroreck, the voltages, everything should be okay, no problem.
Just for me to give a bit of an explanation, basically when we talk Eurorack, it's a standard format of modular synthesizers that you can now. It's been around. Eurorack has been around. Was introduced originally by Dupfer in the 90s, and I would say in the past 10 to 15 years, it's become something extremely hugely popular. And there are many manufacturers, I would say thousands, that build modules, and the modules could range from sound noise-making devices such as oscillators to other components that would build up a typical synthesizer. But you would have even effects and other aspects. So people might want to build a Eurorack just for it to process sound, but people would want to build a Eurorack to actually create sounds and for it to have sequencers. So what Marlon is building here, it fits into this standard format. But Marlon, again, we'll talk a bit about the mechanical stuff and what Heimbach said in his video. But let's continue now going through the different devices you have here. Maybe you can demonstrate a bit, please.
Right. Since we're speaking about tape, I will go directly to the other tape machine, which is a small reel-to-reel. Reel-to-reel machines were always something that I liked to mess around with, and I wanted to make it small enough to fit in a Eurorack format, as we said. So I 3D printed 2 plastic reels, smallest I could, and I used the head from a reel-to-reel to take audio from a cassette tape from one second. The faint audio that you hear is nothing much. It's a reel I found in a flea market. I don't know who's talking, it's a guy. I cut a piece of it, reeled it in, and I'm playing it in reverse. So you create these sounds that honestly don't make sense, but can be filtered, and in certain types of music, it can be used. I've heard DJs locally using such sounds to create music with, which was amazing in my opinion. This is a small reel-to-reel.
So here, this is a very interesting aspect that you're mentioning here. You're mentioning the aspect of reusing. You've mentioned that you've opened up faulty cassettes to take out their motors and their, let's say, gears and whatever there is inside for you to reuse. And so you are very much an advocate of reusing old stuff that would otherwise have been thrown away.
You find some unique stuff, unique parts in such machines, which some guy in the 80s put a lot of thought in, but you can just take them and reuse them. So I don't feel there's anything wrong with that.
Also, this concept of cassettes are thrown away. You find a lot sometimes, even you go in a junkyard and you'll find literally cassettes thrown. And there are even producers and composers that reuse tapes and loop the tapes and eventually make so yes, you are very much right on that approach. Okay, let's go on to another device.
Apart from generating signals and generating patterns, you also have to filter the signals. So I found a couple of electrical drawings on the internet that come, for example, from the famous MS-20. There's the filter schematic, it's readily available with just a simple Google search. And you can create the
So this is a filter of an a Korg MS-20 synthesizer, no?
You can take out the filter circuit, it can be isolated from the real MS-20, and you can just create this part of the circuit, which is, in my opinion, the most interesting. You can create, the filter goes in resonance, it's called, and it creates this whistling sound, which then it filters itself and removes most of the whistling sound, because if it really goes in resonance, you will need to lower the volume.
Exactly. It's a very popular and signature of this very popular 7-modular synthesizer that nowadays has been reissued. Okay, let's continue. The next device.
Okay, hopefully it works.
No level volume.
No. Let's see. Only the bottom. This is a simple laser circuit, which can also be filtered slowly with some patience. It's another sound that's coming from a separate module. Let's see if I can. Let's see.
When we say this is typical laser zap, and it's also the basics of any drum sound. So essentially.
Yes, I'm trying to.
Yes.
It takes a lot of playing with knobs, and which is all the time.
So you're using this sequencer to trigger?
If you compress it well enough, the laser sound becomes a snare drum. But it takes a lot of filtering. It doesn't. Anyways, I tried.
Okay, great. So next.
Another sound which is also can be filtered and creates a hi-hat sound is the white noise. It's the simple. The sound you hear is the sound you hear when you're turning channels on the radio. It's just simple static. In fact, the circuit that is driving this is a simple AM radio, and right now it's not picking up any channels, so it's creating this sound which can be filtered.
So this is taken from an old radio.
It's
chip or board.
It's a circuit used in AM tuning. Yes.
Yes.
Then I have a couple of clocks and a wave folder. The wave folder usually. شنو؟
All
right, that's fine. All right.
Okay, so these are wave folders. Wave folders are devices that shape sound.
It's a kind of a filter, but it's folding the wave onto itself. And if you had to look at it through an oscilloscope, it would look like the wave is actually folding on itself. Right now it's just the sound, so it's not. But basically this is the part where it changes from a simple wave to two waves. All right. Oh, yeah.
Now I'm gonna talk a bit about your, I would say, the symbol that you like a lot to introduce and to include in your modules, which is the Vitruvian Man. Maybe and a device that you are using as like the clock for a lot of your modules. Maybe you can give us about your journey on this form of clocking.
So apart from creating the sounds, I focused a lot because I like the idea of the sequencer. I wanted to evolve it. So I started thinking how it can be improved, because this sequencer cannot be synced. It's a simple DC motor turning a wiper. So it cannot be synced to a clock. You cannot activate step by step. So I wanted to fix that. So I moved from DC motor to a stepper motor. A stepper motor is a motor you commonly find in a printer, for example. It's a motor that can be precisely calibrated to make a very, very small percentage of the turn. It's a strong motor, and I decided to go with that. But to do that, I had to turn to digital. Stepper motors require you to focus more on coding and digital, so I had to relearn a little bit about coding and how to drive a stepper motor, because it involves very precise clocks and conversions from pulses to a number of steps. Let's see. I'm driving the clock of the stepper motor using a metronome. This is the only device, or at least one of the only devices in this use case, which I bought. This is a metronome that guitar players use, and it had a beeper that keeps the tempo. Beep, beep. And I replaced this beeper with a circuit so that I could take out a voltage instead of the beep. So I'm using that voltage, which I believe Seiko in this case made sure that the clocks are accurate. And I'm using that voltage to drive my other circuits. Every time the metronome here is giving a pulse, it's driving this stepper motor 1/32 of a turn. So it goes from step to the other step. I also added the function that I can turn this single step into 2, and I can also turn it into 4. And then in reality I can turn it also into 8. So that I can turn a 32-step sequence in 16 or 8 or 4 steps. Each pin works exactly like the other one. It sends a voltage, which I can then, in this case, I edit to make it variable. I can also have another channel to make it just a pulse. I added the DB37 connector so that I can put a ribbon cable and connect it to my already existing devices, so that I don't put them to waste. I can reuse them with this new, more accurate clock.
Okay, so this is very interesting. So instead of having a lot of wires connected loosely between your devices, you're reusing something which was before was used for printers in the 90s.
Yes.
Before USB, it was called the parallel port, if I'm not mistaken, and you're using the same connectors, those ribbon cables,
yes,
to be able to connect your boxes.
I needed some kind of connection that has at least 32 conductors inside. So I use 37, DB37, and I'm happy with it.
Yes. So there, what you're showing is a sequencer that the knobs can affect pitch, for example, or can affect another
yes,
device that takes control voltage, such as a filter. And those red and white switches there, those small switches are where the trigger. The step, a trigger that is associated with that step, and as a master clock, you're using the stepper motor there with the Vitruvian Man. There was this sort of evolution that you had from when you started experimenting with different contactors. Maybe you can go through your journey as you started exploring stepper motors, as you were saying. I see in the other suitcase a large,
yes,
a large version of that module there. I think that was one of your first.
This was the in between, yes, between that one and this one, because before ordering PCBs and designing and wasting a lot of time and money, I wanted to create something rough just to see the proof of concept working. So I created it with plexiglass, and it's really rough if you look inside, but it used to work at least. And it's the step between that one and that one. It has the same software inside. And I saw that it was working, so then I transferred everything to that one. And as you can see, I already had decided to use the DB37 connection. in that case.
And you're using like game console switches there too to make it a bit more fun, no?
These are buttons that I found. I try to go practical with the components, but sometimes you also need to consider that I'm investing a lot of money in this. So I found a cheap deal online and I bought a bunch of buttons, which yes are big and red, but they suit the purpose.
So let's move now to Eurorex. And to your relay, I would believe, the module. Can you take us through a bit about the story of this module and how, and eventually it was featured also by Heimbach in his video?
Yes. So basically the idea came from moving knobs all the time and trying to find, sometimes you end up swaying the knob left and right just to hear that nice effect. So I decided to automate this. Some knobs don't have SAB input, so I decided to put a motor on it. So the motor is turning the knob. The motor needed a limit, so I created this wiper. There is a motor turning a wiper, going left and right like the car wipers. And at the same time it's turning a potentiometer with itself. That's all it is in reality, and it's creating an output voltage. Some people like the mechanical aspect of it. I was surprised. Some people like the sound that it's creating, which at first I didn't like it because it makes a lot of sound. Modular synthesizers usually by themselves are silent, but this one's creating noise because there is a motor with a gearbox. So, but some people liked it. Heimbach seems to like it, and he seems to like also the current draw because as a Eurorack device, it takes quite a lot of current. And some of the power supplies in Eurorex are not designed to give this much current. But again, Heimbach seems to like it, and he said that it's creating a voltage drop on his supply rails that are affecting his other modules, and he liked it just for this fact.
Yes, so essentially what there is a motor that is driving a pot,
yes.
A potentiometer.
Exactly. The motor driving a potentiometer, that's all.
And this is ideal if you would like to include it in a modular, so that you can do something called low frequency oscillation, which is can be used for pitch bending, for filter shaping and other stuff. I don't know if you would like to add anything else, anything more on and maybe show us some other of your devices.
Most of them are. I'm focusing too much on sequencers. I believe that the pattern to drive the sound is more interesting, in my opinion. You can create polyrhythms, they are called, which is sequencers basically driving other sequencers, and the options are almost infinite.
And so if anyone would like to buy or to get any of your modules, what should they do?
For sure, you can follow me on Instagram, but right now I'm not focusing on selling, I'm more focusing on creating. I don't post too much, but I will do my best to keep everyone, if they are interested, I will provide material on Instagram. Yes.
Okay, and the future is more sequencers, or are you thinking about?
Yes, I'm thinking about evolving the 32-step sequencer in something much bigger and standalone, because as it is Eurorack size, but it's not suitable to go in a Eurorack, because the current draw is about 2 amps, which is crazy if you talk about Eurorack. It's not possible to put this on a power supply. So I will create, hopefully, if everything goes well, I will focus on creating a standalone sequencer, possibly something to do with 1 or more clocks, its own clock, and maybe something to do with envelopes. But I'm still thinking about it.
Yes.
I'm sorry, I had a question. You were talking about programming, no? I'm a computer programmer and I'm also a musician, but I've never gone so far as the Euroracks. What language are you? Is it assembler or basic machine language, or Python, I don't know. So just curious.
No, I didn't go that much in detail to go into assembly, but I knew C code. I refreshed C code in my head, and when it comes to Arduino, yes, you can use C code.
C code?
C code.
Pardon?
Simple C code, yes.
C code,
yes.
SQL?
No, C.
C.
Oh, C. Oh, C.
Just C.
Oh, sorry, C. Yes, C programming language, okay.
C program.
Yes. Thank you, sorry.
Okay.
Can I
Yes.
answer the
Yes.
gentleman? A very popular platform is the Teensy, which is basically like an Arduino. And that has Python, which is used for it. And I believe there's also the Arduino Uno, and the Teensy 3.6 and the 4, but at the moment the chips are a bit scarce.
Oh, okay.
The 3.6 is something which is not there. There's also something called the Arduino, which uses a different chip, but it is basically the same.
Thank you for that.
You're welcome. If you know Python, you're in.
Would you recommend Eurorack as an introduction to synthesis?
For sure.
Like over standalone hardware modules?
It depends what you're after. There are different sizes of Eurorack from very small desktop Eurorack. I would say enclosures, because you would need to buy an enclosure and you start building. But it depends what you're after. If you're after something that helps you to, let's say, improvise. But Eurorack, you need to learn how to connect the modules, but it is a great educational, I would say, way to introduce yourself to synthesis. Myself, who started in the late 80s, though it was a time when synthesizers were going from very interactive to extremely hard to program. We used to have buttons, two sliders, and a small display. And yet, I taught myself something called a frequency FM synthesis. With Eurorack, you go back to the origins of synthesis, and that is where you learn how truly a synthesizer works and all the different departments inside the synthesizer. So yes, I truly recommend it, because it's a way that helps you to learn properly how a synthesizer works. Yes.
Can I also suggest something? It's a project I also work with Edwin as earlier, I would suggest searching on the core little bits. They're kind of like Legos, but you can actually build a synthesizer in various manners, kind of like a modular synthesizer. And it works with magnets. You just stick one module to the other. So you know.
Yes, there is a brand called Little Bits.
Little Bits. Really very similar to Lego, but not so complex, obviously. But you just take the oscillator to a filter, for example. You can just use those two modules. Have also a very small speaker, which also works with a magnet. So it's really easy, and it's color coded also, so you cannot switch ROM parts. And maybe it's an even better introduction. I think it costs around 100 euros or something. And it's really, the sound of it is really good also. So that's a very good sound.
The thing with Eurorack, you have to be careful, but although nowadays there are brands, established brands, and I won't be making any adverts here, but that are creating modules that are clones of classical modules at a fraction of the cost of the original modular. So basically today, thankfully, there are one at a, I would say, moderate budget can already build quite a powerful setup. I would say when the big craze of modular started, it was quite an issue, because one could get addicted and then end up spending money. But today there are a lot to choose from, besides the kit that Toni was mentioning.
I have another question. I'm fairly new to this. I noticed most of the modular synths essentially monophonic, like for example the MS-20. But then when I notice polyphonic synths, their modulation matrix, and as in their modulation matrix has to be digital when they're polyphonic. I'm just curious.
No. With modular, you will have modules that can create chords and modules that you can connect. Obviously, here we're not going to go to the concept of CV and gate, but yes, as you're stating correctly, the very first synthesizers were monophonic, and they were controlled with something very simple called the CV and the gate. But from the mid to the late 70s onwards, the polyphonics started appearing, but then the issue was how to control them. And then that is when the digital interfaces appeared, such as DCB from Roland and eventually MIDI. In modular, you can still have the core of I would say your oscillator could be a polyphonic oscillator that outputs chords and which then passes through the other components such as a filter and envelopes. But obviously, there's something called paraphony, which is like one envelope for all your notes, which comes into effect. But yes, you can modular, since there is no limit, you can have a polyphonic element in them too.
I have a question for Marlon, because I know what the Mandala module there does, but I would like you to explain, because it's, especially for the people who know synthesis, it's a very powerful tool in my opinion, and it looks good, and it's
This is, as I said, I'm trying to evolve the idea of the sequencer into something more special, possibly incorporating envelopes. This is an 8-step sequencer, same idea of the other ones, with a wiper turning and hitting 8 different pins. But each pin goes directly to create an envelope. So it's 8 separate envelopes in sequence, which can be skipped. It can be go 2 at a time. It creates a sequence of envelopes, which can be independent or in a chain on the same line. It's something I'm still working on. I got it to work just yesterday, in fact. It works, but I'm sure it needs a little bit more fine-tuning. And I need to design some, because as you can see at the back, it's not pretty. And some of these aren't pretty at the back, in fact. A lot of hot glue and wires and connections, which...
It's a prototype.
It's a prototype, basically, yes. It's the first time I tried it, and now I know what I can improve in the future model, yes.
What sort of envelopes do you have there?
They are relatively simple envelopes. They are just AR envelope, attack release. I could have gone for the more complicated ADSRs, but to design ADSRs analog, it will take much more space on the PCB, and it's much more complicated to troubleshoot and debug, so I just went with AR. But I leave the option open for the future to make them or digital ADSRs, or I leave it analog as is because I prefer analog, and make analog ADSRs, yes.
analog 8-step.
Analog 8-step, mechanical, yes.
It works. Any other questions? Well, thank you for the participation. I really enjoyed seeing people interact with Marlon. Again, for the second time, well done, Marlon. Thank you.